Hi folks, so the question we have in front of us today guys is a development question here, and it's based from the Understanding Technical Graphics textbook. The question is based on this little walnut chip box here, okay, walnut whip box here, sorry. It says the walnut whip box shown across is based on an equilateral triangular prism. Using the dimensions indicated, draw an elevation of the prism looking in the direction of arrow A, so arrow A is looking in this direction. Draw a plan of the prism looking in the direction of arrow B projected from above, and then draw a complete surface development of that prism. Okay, so first of all, it's an equilateral triangle that we're looking straight at it, so all angles within an equilateral triangle are 60 degrees, and one of the sides then is 90, okay? And then we can see that it has a depth here of 25 millimeters. So elevation is going to go roughly on the right hand side of our page. That's where we're going to start it, just because the arrow is facing towards the right, so we'll put the elevation over there. Okay. So zoom out there and just adjust my camera there. Okay, so what we're going to do now guys, as I said, is we'll start off by putting in our XY line. Okay, roughly somewhere in the middle of the page is where I'm going to start it. XY line somewhere in the middle of the page, well sorry, to the right of the page there I should say. And on the right of the page, what I'm actually going to do is I'm going to draw in the elevation view. And we know that the elevation, okay, the triangular, equilateral triangle, okay, has a length of 90 millimeters. So, if it's an equilateral triangle, that means then that the angles, okay, at the bottom corners are 60 and 60. So project up at 60 degrees this way. And if I project up from the other corner at 60 degrees, there is my equilateral triangle. I can heavy that in. That is my elevation drawn. Nice and easy. Okay. Having done that, I now need to project down a plan view. Okay. So if you think when we're looking down on top of it, it's like the direction of my biro there. I'm looking down straight on top of it. So there's three obviously sides to this. There's obviously a front, there's a back, okay, and then we've actually got three sides. Side here, and there's actually a face on the bottom as well, okay. So altogether there's actually 5 faces on this object. So looking down on top of it, we do not see the base, but we do see this face a bit, and we see this face as well, okay. So projecting there from our elevation, project our lengths down, project this down, probably project it a little bit further. Project the top down, because I'll see that as an edge, and this guy down. And I'm going to start it, I'm going to keep a distance of about 10 millimeters between my views. You don't have to. It can be anywhere smaller, or it could be a little bit bigger. Starting there, okay, and then I know that the distance or the depth of the object is 25 millimeters. So I'll measure down 25 from there, and there you have it. That is our plan view drawn. Just going to heavy that in. So, heavy that in there now. So as we can see there, looking down on top of it, we would see a line in the middle, okay, as a heavy line there, because as we look down on top of it, we would see that line there as an edge, okay. So there's one side, there's the other, and obviously there's the bottom face. So now what we have to do guys, that is part A done the elevation and part B done the plan. We have to do a complete surface development, okay? And you could develop this, as with many developments, you could develop it many ways, okay? I'm going to literally do it this way, where I have maybe the back surface, the bottom, the front, and then I have the two sides coming out, okay? So I'm going to take this line across here, and I am going to take, okay, my compass, and I'm going to take a true length of one of the sides there. Because essentially, that side, that 90 millimeters there, should be the same here and here, and we can see that it is, okay, and I'm happy with that. So I could, starting off, make a mark here, because I know all three of those sides connect together, okay. So from here I'm going to mark out 90 twice, so that'll be 1 from there to there, 2, and then finally, and hopefully it fits on my page, and it does, 3. Okay, so I'll mark that out there as well. Right, and at this point here, I know that all those sides come down 25 millimeters. So I'll mark down 25. I could take it from here, but I'll just mark it down, just simple. mark it the whole way across, and then do my connecting lines. So that is the 3 side faces of my surface. Okay, in essence this would be the bottom, this would be a side, this would be a side. This one in the middle is technically this one here, this one might be the left, and then this one is obviously on the right. And at this point now, it is possible that we could actually attach an equilateral triangle, okay, one up here, and then you would have to have one on the opposite side here. And because it's an equilateral triangle, I could put one here, I could put the other one here, I could put one here, up here, it doesn't matter, here, here, or if I wanted, I could do alternative places where I could go here, and vice versa, okay? So at this point, it's actually quite easy. I'm going to do the top one here, and I'm going to keep it quite symmetrical. So that's at 60 degrees there, and this is at 60 degrees here. And if I'm accurate, it should match up with the height of this. We'll just check it there, and we can see that it does. I'm more than happy with that, okay? So I could have transferred my height across there like that as well, okay? Another way you could actually get it, a little bit of practice on triangles, when you have the length of the side, and I know the length of the other side, I could come down here, and this is where I'm putting the front face, down here and do that, and then from the other point, do that, and there we have it. That is the tip of my base triangle. I'll put that in here first like this, and there you have it, okay? That is the surface development of the object, okay, where we have the front, the back, the bottom, a side and a side, okay? And now I'm just going to heavy those in, nice and easy, okay? Just understanding obviously on the object and its various faces. Actually heavying this guy up here. So all the outside faces, or I should say outside edges, are actually going to be in heavy. And in this case, we'll actually have just some hidden details, or not hidden details, apologies, hatched lines for our bending surfaces. Okay, in developments, you always have hatched lines for any surfaces that bend over. Okay, so if this object, if I was to cut it out of a piece of paper, out of this piece of paper, we would see that it would fold together to make that walnut whip shape. Okay, so inside here, the front surface will fold back up straight, so therefore that line there is a fold line, which I'm going to put in with these hatched lines here now. Okay, the same with the back surface, so that folds up like this. Okay, then the side surfaces, that one will fold back up obviously into an angle of 60 degrees. And the exact same with this one here, where it'll come back up into an angle of 60 degrees. Okay, that's that question done there, guys. Not too tricky, okay, but just understanding it gives us a little bit of a recap on triangles there again, and the angles inside here of an equilateral triangle, that those angles in there, okay, are always in an equilateral triangle 60 degrees. Okay, and obviously then understanding where we could put the triangular faces. One could have gone here because technically when that folded back in, all the angles are the same, so it still would have worked out. Okay, hope you found that helpful, guys. That is the question complete there.